In this example, we're going to look at the plate production tool, which is found in the bottom here of the drawing tab. And this tool is intended to apply to toolpaths and designs in the software in a very similar way to the concept of mail merging in a conventional Office application. You may already be familiar with this idea, where you create a template letter or envelope address layout, and you can use a database then to populate each of those fields automatically to do a repetitive task of creating letters with individual addressees on them. In the same way, our software can import a database file and replace the values that have been used to calculate different toolpaths. And so by doing this, you can create an array or layout of repeats of the same design, but in each time inserting details from an external file. So it's probably easiest if we just demonstrate this process. If I select here this template, which we'll look at in more detail in a moment, but essentially the template can comprise any number of toolpaths, but it has some special fields here which are denoted by the double shriek or exclamation mark on either end. Like I say, we'll look at creating those in a second. Let's just run the plate production tool to see what happens. So this brings up this dialog, which gives us some details about the sheet size. So in this case, what we're going to do is we're going to lay out as many as we can fit into our 12-inch by 8-inch sheet here, and we need to find the file that we're going to import. Now the file is that we can bring in is a normal text file, and the text file can be separated in a variety of ways. The example I have here is an export from an Microsoft Excel worksheet. Here's the file after it's been exported from Excel, just shown in Notepad, which is the normal text reader in Windows. And you can see it's a very simple file structure. The top line here are the headings that have come from the spreadsheet, and then underneath that is a list of values for those headings. So we have the first name, surname, department, age and sex for each of these individuals from the database. And you'll notice that each value, the first name and the surname, and then each of the other fields here are separated by a comma. And because of that, it's called a comma separated values file here, CSV file. So we just need to make sure that we've chosen the right separator. You can find files which may be just separated by a space or perhaps a tab, but the comma is the most common thing. So with that selected, I can select this file. And now you can see that the software has identified the same content here in this box at the top. We can see that the first row is just column names, and so I can make sure this is selected here to ignore the first row in essence, which is quite handy. And down here, these variables under variable assignment, name and department, have actually been located from the selection that I had when I opened the plate production dialog. So with these vectors selected, I then clicked the plate production dialog, and it looked at the vectors that I'd selected at that point and found two of these specially marked up entries, one called name and one called department, and they've now appeared in this variable list. So I can take the variable from my template, name, and I can choose where to assign it from our data. So I can say the variable name here is going to be assigned to, and here I see the values instead from the file. And the file that I imported had, if you remember, columns for first name, surname, etc. So I'm going to assign my template name to be the first name from the file, and the department I'm going to assign to the department field or column from the file. With those selected, I can just click calculate. I've also got the create toolpaths selected here, and because there were toolpaths associated already with those vectors, when I close this down, we can see that not only have we laid out now our 2D artwork, but if I turn to the 3D view as well, we can see that the toolpaths associated with that artwork has also been duplicated. Because we've got, I think there was 14 individuals in the file, they didn't all fit on the one sheet. So if we go back to our 2D view here and I go to the layers, you will see that it's created a series of sheets, and it would create as many of these layers as I would need for all of the badges that I've asked for. If I hide sheet 1 here and turn on sheet 2, we can see that the extra 2 have ended up on a separate sheet. So when you've calculated the plate production, you might end up with some layered results to deal with the idea that you're going to have to cut these on more than one sheet. Okay, so let's that's the basic principle. Now what we want to do is look at how we produced the template and just go through the process a step at a time. Okay, so now I want to look at the plate production a step at a time from first principles. So we're going to actually create our series of badges from a completely blank sheet, and I'll start by creating a new file. And our blank sheet's going to be 12 inches by 8 and an 1/8 thick, and we're assuming it's some sort of thin acrylic sheet or the sort of material that you might manufacture small conference badges or something of that sort. And so we just click OK. So that's created our sheet from which we're going to cut our badges. The next thing I'm going to produce is just the boundary of the badge, the edge of the badge, and I'm going to use the Draw Rectangle tool here. I can start to draw a rectangle and just get it drawn by eye, but also it's quite handy to come back in here and have some fixed sizes. So I can just come, having started to draw this rectangle, I can come back now and actually force some very precise values. I can also put on a radius external corner here using one of the options on the corner type, and there's a 1/4 inch rad to that, and when I click apply, my drawing in the bottom here is reset according to the properties I've just put into that form. So I can close that down and I now have a 2.5 inch by 2 inch badge outline. The next thing I want to do is bring in the company logo. Now typically that's not something that you'll design directly. You might find that you're sent that, or it's something that you'll need to generate externally to the product. So to sort of show how that might work, I've got a file here that we're going to import. So I'm going to import vectors, and my logo, my Vectric logo here, is an EPS file, an encapsulated PostScript file, which is a common vector format. As it comes in, they're all separate vectors, so I'm going to press the G key to group them all together. But that's now the company logo, and that's going to stay the same throughout all the badges that we make. So this bit is a sort of fixed part of the design, and I'm going to tuck it in at the top of the badge here. But I'll take the opportunity to show you the layout, the alignment tool here, which is quite handy for this sort of job. So with the alignment tool, we can actually align things very precisely, either in the middle of an object or to their edges. So in this case, I want to align it to the middle in X inside this object. So if I select the thing I want to align and then I hold down the Shift key, so I'm also selecting the thing to which I'm going to align it. So in this case I'm going to align the Vectric text inside this box here. I can now choose to center across the box, and it will just move it into the middle for me. Another handy tip is, with that selected now, I can use the arrow keys on my keyboard to nudge them around, and by using the arrow keys and only using the up and down in this case, I can keep it centered and just decide where in the vertically I want to position this text. So that's just using the arrow keys. So there's my logo. Now the next thing we want is the name of the conference attendee and the department that they're from, and that's the information that ultimately is going to come from a database or an Excel worksheet in this case. So all I need to do at this point is put a placeholder for the template to know where to put the text when it receives it from the data file. And this is the bit that's just slightly special, in that we need to mark this data in a unique way for the plate production tool to discover later on. The other thing that's worth pointing out is when we come to replace the fields that we put in here, we don't know how long the words are that are going to replace the marker. So we're going to have some people with very long names and some people with very short names. So we do have a design decision to make at this point when laying out the template. We can either fix the size of the font that we're going to use and make sure that we choose therefore a size that will cope with all of the different lengths of word that are going to come in. Or we can do something perhaps a little bit smarter, and that is instead of using the text tool directly, we can use the one next to it, which is to draw text within a vector box. So just to emphasize the difference there, if I open the Draw Text tool, you can see that it asks me very explicitly to put in the size of the text that I want to create. And when the plate layout tool uses that text, it will continue to use the fixed size that I've given it, and that may or may not work as it has different word lengths. So I'm not going to do that. I'm going to use this tool instead, the Draw Text Within a Vector Box tool. And this doesn't ask me about the dimensions of the text, because when I opened the tool I had this box selected. Yes, just make sure I emphasize that. With this box selected, when I open this tool, it finds the dimensions of this box and it will fill the dimensions of this box with effectively resizing the text accordingly so that it will always fill this box. So I'm going to type in the first field, and this is the special markup. The markup we use is 2 exclamation marks or shriek characters, then the name of the field. In this case it is name, it's going to be the conference attendee's name, and then 2 more shrieks or exclamation marks at the end as well. So we're effectively bracketing the name that we're going to replace with this special markup of 2 exclamation marks at the beginning and the end. I'm going to use a single line font, but I'm going to use the 3-line version of Helvetica. So these are from the single line font selection that's part of the normal install of your software. I'm going to click the Helvetica 3-line version, and that's it. I don't need to specify the size. I can just click apply now, and it's made sure that my name field has filled the boundary that I had when I came into the tool. And the crucial thing is that that property of this text will be kept. So as the plate production tool is used, it will put different length words in here depending on whether it's a short name or a long name for the individual, and in each case it will automatically continue to resize that text so that it always fits inside the boundary. So that tool is very, very useful for this particular feature. So that's the name field. We're also going to have the department that this particular attendee is from within the company. So I'm going to do the same thing again. We select the boundary and then select draw the text within the boundary that we've got. I'm going to use the single line version of Helvetica for this example. Type in the same markup, shriek shriek, then the name of the field, which can be anything you like, just usually a meaningful name that reflects what the field content will be, and then 2 more shrieks to bracket the field. Again, I'm going to apply that. Initially it's put it in the center of our box, but if I close that down and we zoom in a little bit here, I'm going to just select the department word there, and I'm using those arrow keys again to move it down. I don't need to do alignment on these fields because the text tool has already aligned these in the middle of the selected box as part of its normal creation process. Okay, so that is the badge artwork laid up. The next step for us is to apply toolpaths to each of these vector shapes that we've created. To create the toolpaths for these vector shapes, I'm going to move across now to the Toolpaths tab, and I'm going to use this convenient button here on the Drawing tab, which will move the focus of the interface across the Drawing tab for me. So it's undocked, it's docked out the toolpaths and pinned them for me, and it's hidden away the Drawing and Modelling tabs temporarily while I think about toolpathing. So these buttons are very handy because you tend to work in this normal workflow with the software. Okay, so the first thing we're going to do is we're going to make the cutout path, which will cut the boundary of our badge out, and I'm going to use a conical sort of tool for this. I'm going to use basically the same engraving tool for all the toolpaths, just for convenience, but you're not bound to do that. Depending on your machining setup, you can create different toolpath types. So I'm going to use a conical tool here, and I'm going to leave a couple of bridges as I cut this out so that we'll be able to press out our badges from the piece of plastic sheet at the end of the process without them flying out on during the cutout. So I'm going to use the profiling toolpath strategy to make my cutout pass. So I click that with this boundary selected. I'm going to select my engraving tool here, which is a small fine-tipped engraving tool. And then what I could do here, the cut depth's actually already set, but just to show you how I found that cut depth, for the purposes of this final pass, this cutout pass, I want to cut right through my material, and there's a very convenient way of finding that using what's called the calculate edit box feature in the software. And that means there are certain special values you can put into many of these little edit boxes which will find for you useful bits of information about your job. So in this case, we want to use the Z thickness of my material, and instead of having to go away and check that and make a note of it, if I type in Z and then equals, as soon as I press the equals button, it will replace the letter Z with the Z thickness of my material automatically for me. So that's pretty handy. We're going to do something a little bit more sophisticated in a minute when we create the tabs, but the calculation edit boxes are really good for finding things like the X, Y dimensions of your job, the Z thickness, and there's various others which are detailed more fully in the manual. Okay, so our tool's selected. I'm going to machine outside of this boundary, and I'm going to add my tabs to this toolpath. And my tabs are going to be very short. They're really just going to be little tiny sprues that I can press out. So 0.1 of an inch in length. Now this thickness I've calculated again using the edit box idea. So in this time I want to actually use 1/3 of the thickness of the material. So my tabs can only be very, very thin. They're going to be 1/3 of the thickness of the material. And rather than do the math in my head, I can do Z divided by 3 equals. And as soon as I press equals, it replaces that little formula with 1/3 of the Z thickness without me having to work it all out. And now I just need to position, so that's the length and thickness. I just need to position where the tabs will be now. I can either choose a constant number or use an automatic process here to put them in, or I can simply come across to my view. In this case, this is the easiest thing, and click where I want the tabs to be. So I'll click for one on the right and one on the left, and the tabs are just put in place for me with little markers so I can see where they are. To delete them, you would just roll over those markers and click again, and that would delete it. So I've got 2 tabs, one on either side, and that's really all there is to it. So I'm going to call this toolpath my cutout. So I just put the name in there and click calculate, and I get my cutout paths here, which we can see in the 3D view. Okay, so I'm going to go back now and do the text. Now the text, in both cases, I'm going to use a quick engrave strategy, so I can select both blocks of text in one go here. And what I'm going to do is just use a simple outline strategy. So if I click the quick engrave toolpath strategy here, we can see that I can just use the default setting here, which is to outline them. I don't actually have the option to use fill in this case because if you recall, I've created these from a single line font. So we have single lines in here, which obviously we can't fill a single line. You know, the shape includes vectors which are not completely closed, and so we obviously can only fill things that are a closed shape. So I have to use outline in this case, which is fine though, and I'm going to just set the depth or pressure for the quick engrave toolpath. So remember, the quick engrave toolpath is actually the strategy we use if we had a sprung loaded or floating head engraving tool. And I'm going to use the same engraving tool that we used for the boundary just for convenience, and select our text again, and that's it. I'm just going to calculate that, and we get our engraving toolpath. When I close this down again, we can look in the 3D view and see the toolpath we've just created, which simply, it's the simplest of all toolpaths. It simply drives our tool along the boundary that we've defined, and the idea here is it's really just going to scratch the surface of the tool, of the material. The final thing is to do the logo, and I'm going to use the same toolpath again. So I select the logo, and this time the logo is a series of entirely closed shapes, so we can use the fill option in this case. So I'm going to boundary round and also come back and score a hatching pattern over the surface too. So with that selected and the same tool before, I can come in and see that. We can see the results previewed there in both the 2D view and of course the 3D view as well. Okay, so now we have all of our toolbars. We have the logo, the name, and the boundary. And that really is all we need to do to set the toolpath up ready for the plate production. So now if we save this file, this is a complete template that we could use time and time again. Okay, so the final step then is to use this template to actually bring in our data from an external file and merge the data in to repeat this badge design, but with actual names and actual departments replacing these 2 little placeholder fields. So really what we need to do at this point is go back to our drawing tab, so I'm going to use the same switch option as we used earlier on when we switched to toolpathing, because we're going to focus again on the 2D artwork for a moment. What I will do though very quickly is just turn off the visibility of those toolpaths so we don't see the markup in the 2D view, obscuring what we're doing. So here is our badge template, and what we're going to do is select all of that. That is all the artwork that we intend to repeat to make each badge. So with that artwork selected, I'm now going to open the plate production tool down here on the drawing tab. When I open this tool, immediately it's going to look at the artwork that was selected when it was opened, and it's looking for specially marked up bits of text. And the special marked up bits of text are the ones which are begun and ended with the double shriek or double exclamation mark symbols at the beginning and end. And it's immediately found those. It's found the one we called name and the one we called department down here. So we'll come on to that in a second. Let's look at the sheet size first. It's picked up the sheet from our current model size here, which was 12 inches by 8. That's fine. It's also found out what the plate size will be. How big will each badge be? And it's found that from the boundary that we selected, and that's right too, 2.5 by 2 inches. Now we get to choose a little bit about how we lay out our plates within our sheet. And just as you would for, say, a printing of labels, we can define the margins. So we can either have an equal margin all round, as I've done in this case, where I just fill in one value, 0.25 quarter of an inch, and I've got this checkbox on, so it's put them in here. Or if I uncheck this, I can set every margin independently. But for this example, we're going to have a quarter of an inch margin around the edges, and we're going to space our badges by quarter of an inch as well. So there's a quarter of an inch gap both across and between each column and between each row, and again they can be set independently. The number of plates, so the number of these that we're going to fit in here, can be calculated for us to be the maximum amount that it can fit in, and that's what we've got here. With this option selected, we've auto calculated the maximum number we can fit, which turns out to be 4 columns on 3 rows. In other words, 4 by 3, we're going to have 12 badges on our sheet. That's going to be important because in a minute when we look at the data, we might find that we need to do more than one sheet. The final thing here is that we have got toolpaths associated with our artwork, and so we might as well, at this point, we can actually have it find the matching toolpaths and reproduce those as well. So not only will it produce a series of copies of the artwork, it will also copy the toolpaths. So we're going to do that. And now we come to the other side of the form, which is really about how we bring in the data and which for the fields we attach which bits of data to. So the data to engrave form here, we start by thinking about the file that we're going to bring in. The file that we have to work with here is an exported file from an Excel worksheet, and it uses commas to separate each bit of the data, but you have the option at this point to decide and indicate to the software what is used to separate the data in the file, and these are the usual things that you'll find, tabs being very common and spaces. So when we import this, you'll see as well that the first row should not be treated as data, but is in fact the name of the column. So in other words, it's the name we've given to each of the data items. So when we import the file, we'll see that more clearly. I'm going to bring in my plate production CSV file, comma separated values file, and we can see here that this is really what this checkbox is referring to. It's saying take the first line and assume that that is in fact the labels for each of this data. So the data is in the form of first name, surname, department, age, sex, and that helps us down here when we do the assignment. Okay, now it tells us that the number of plates in that data there, so if we were to count the number of elements in here, not counting that columns entry, we've actually got 14 individuals for our conference, which we found here. Now remember, we've only got 12 plates we can fit on a sheet, but the software will automatically sort that out for us, but at the end we'll find that we've got a sheet of 12 and then the extra 2 on a separate sheet, which I'll show you in a minute. But that's useful to make sure that that matches what you're expecting as your number of samples. And now we come down to the final bit of the process really, which is to take our labels that we've put in our template and tell the software which of these bits of data to use to fill in each of these labels. So we take our variable name here, so I select name and I tell it to assign name to one of the bits of data that it's found from our file. There's also a sort of special extra one here, which is a counter, which is in square brackets. Now that will actually put in the number of this item, and sometimes that can be very useful. So while it's not explicit in the data that, for example, Susie is number 12 on the list, the software will find you, use that value and create that value for you if you want it, and that can be quite useful. But in this case, we want to set the name on our badge to be the first name of the individual. We're going to have quite an informal conference. Obviously, it could be the surname. We're going to use the first name in this case. And then for the department, there is actually a field in our data called department, and that's obviously the one we want to use there. And that's really all there is to it. I've set up now everything the software needs to know to create duplicate copies of this badge for every person it finds in this data set, replacing the particular fields with the particular bits of data that I've specified. And when I click calculate, it goes away and creates the sheets for me. So there we are. There's our sheet of the first 12 people. If you remember, it's 4 columns and 3 rows, just like it said it would. But let's have a quick look now at the the layers that we've got. So it's created quite a few layers for us. If you're not familiar with layers, it's a really handy way of organising the 2D artwork when you've got quite a bit going on. In this case, we are looking at sheet 1, which was created by the plate production tool for us. We can also switch off the visibility of that one and switch on sheet 2, and there are the extra 2 that it couldn't fit on the first sheet, so we can look at those separately. We can also find our original artwork is still there on the original layer when we first created this template. So it's created our artwork for us entirely separately, so you can keep your finished results separate from your original template work. The other thing to highlight is because we have the toolpaths selected, if we go to the 3D view, we can also see the toolpaths that it's created for us. So we can simulate and check that that's okay. One thing I want to highlight before we look at the toolpaths in more detail is, if you recall, we selected on our, when we created our template, we used the text within a vector box option, and you can see now how that's paid dividends for us, because where we've had long and short words, so in one case the department was accounts here, let's look at it more clearly in the 2D view, accounts versus product development, we'd have really struggled if we'd used a single size of font. But instead we've let the software worry about that. The software has found whatever font size it needed to continue to fit the field inside the box, and so that's an important feature when you're doing plate production. The final thing I want to look at in this demonstration is the structure of the toolpaths that have been created from our plate production tool. So for that, I'm going to go again back across and look at the toolpaths tab, and you can see here that we're currently looking in the 3D view at a series of toolpaths called S1 Cutout, S1 Quick Engrave 3, S1 Quick Engrave 4. Now obviously the names of the toolpath match the original template's names, and the S1, as you've probably guessed, refers to which sheet that they belong to. So we've managed to fit the first 12 badges on sheet 1, and these are the 3 toolpaths relating to sheet 1. If I switch those off and we switch on the S2, we'll find that on the second sheet we only had 2 more badges left, and these are the toolpaths that relate to sheet 2. So when you come to export your toolpaths for machining, so you want to save them off, you'll probably make you definitely want to make sure that you save them in the sheet groups here. So save them as a separate set of toolpaths, sheet 1 first, and of course when you select them you can have this option to output the visible toolpaths into one file. In our case, because we've used the same tool for all aspects of our badge design, we would be able to save all the elements for this sheet as a single toolpath with or without a need for tool changing support. Obviously, if you use different tools, you will either need a tool changer to support a single output file, or you would need to output them as a series of toolpaths so that you could swap the tool between each strategy. Okay, that's really all there is to plate production.